The need for a roof over one's head, to live in a house, to not be homeless is as basic and as fundamental as the need for food, for clothing, for work. Housing for all is, however, a distant dream, a desperate struggle for the millions of poor, the dispossessed, and those who subsist on the margins of human society. It is inconceivable to imagine so much cement, steel and concrete so that every Indian is secure with a roof over his head. Such an expenditure of energy and effort would sooner bury us in an environmental disaster. The scale of the problem is so huge that it invokes despair. Yet, in just such a gathering of despair lie the first sparks of hope and a call for search. This occasions the use of knowledge and technology to fashion alternatives, housing technology and building materials that are abundant, easy to use, durable, dependent, energy efficient and eco-friendly. Building materials and housing technologies that create a comfortable, secure home but do not burden the earth, nature or humankind. This search has fashioned many paths in new directions. It is among them that bamboo beckons us like a beacon of hope from the distance of a past of many centuries with all the accumulated wisdom and experience. It therefore embraces the present-day technology with such warmth. As we walk inside this magnificent bamboo forest, which bestows the same wonder as it did thousands of years ago, we begin to try and understand the story of this search and hope. Those many centuries ago, people grew houses just as they grew food. A small bamboo grove in the backyard gave all the building materials needed: walls, pillars, window frames, lattice network, rafters, room separators, ceilings, roofs, scaffolding, and so on. One needs to keep reminding oneself that more than 1 billion people in the world live in bamboo houses, even in the 21st century. The richness of skills, variety, and innovation is so obviously evident. The Rayang house of the Rayang tribals of Tripura, constructed on bamboo stilts, bamboo posts arranged on a square grid, rafters of whole bamboo culms, and thatched roof of bamboo leaves, a typical hill dwelling. The Mizo house, built by the Lushai tribes, mechanically flattened whole culms in the form of boards as walls, with 3 types of weave structures, doors and windows of bamboo splits. The Adi Galong house of Arunachal uses both wood and bamboo and is built on an elevation. The bamboo houses in Assam and Tripura use bamboo as in fill panels, which are plastered with cement or mud. The roofs are prefabricated panels composed of rafters and purlins lashed together, and for walls, flattened bamboo boards are interwoven and splints combined to form wall elements. The construction principles use many kinds of joints and shutters for doors and windows. In all these examples, learnt, spread, and accumulated over many centuries, the craftsmanship ensures lightweight construction and the ability to withstand high winds and even earthquakes. But this paradigm had limits. It essentially meets a local need with local resource. Also, the bamboo doesn't last long. It rots, splits, and is eaten by pests. Now the question was, can we make the structure last much longer, say 25 to 30 years? Is there protection against pests and borers? Besides growing the house, is it possible to transport it and set it up anywhere? Could the people earn a surplus? Could there be a market? The work and experience of the NMBA during the period 2004 to 2009 came up with a resounding yes to all these questions and wishes, and the answers have come in the form of industrially produced bamboo housing materials and products. Bamboo mat boards, particle boards, natural with veneer or lamination of varying thicknesses and made of bamboo mats, flattened bamboo, sliver and waste, and composites with jute or glass. Bamboo, and bamboo composite roofings and ridges, bamboo doors and windows, trusses, columns and scaffolding, bamboo flooring material, new products like structured insulated panels, whole bamboo pressure treatment for long life. These green building materials are now being manufactured in more than a dozen industrial units that have come up with NMBA's assistance in various parts of the country: Karnataka, Kerala, Orissa, Arunachal, Mizoram, West Bengal, Assam, and Tripura. Many new units are in the offing, which will produce even more versatile items, including beams and columns, which will enable bamboo to be used with the same ease and variety as wood timber. In a short period of 5 years, despite the conservative construction industry wedded to vested practices and the dominance of competing products, the successes have been dazzling. Over 8,000 bamboo structures all over India, supply of nearly Rs 80 crores of bamboo boards for post-tsunami rehabilitation in Andaman and Nicobar Islands, igloo shelters in Kargil and Leh, structures for the armed forces in remote locations, schools in Chhattisgarh and Rajasthan, residential university building at Awantipura in Jammu and Kashmir, classrooms and utilities in Delhi colleges and Delhi University campus, whole bamboo pavilion at Kisama in Nagaland, boat house resort at Kudal in Maharashtra, campus building of National Institute of Fashion Technology at Kangra in Himachal.
In Kangra, 20,000 square feet of space was built in 45 days, which is not possible in cement and concrete. These houses are sent in knockdown condition, packed and are reassembled just like knockdown furniture.
Among the prefabrication technologies on offer in the housing and structures market, bamboo is, by quite a distance, the best green option.
We are working on bamboo composite houses for the economically weaker section. The cost comes down. At the same time, the performance, manifold it is increasing. It is definitely, the very cost effective houses, schools, community centers, all other structures we have developed. And when you go to the shop floor, you will see a house which can be constructed in less than 6 hours.
Let us know why. Bamboo is the best natural engineering material in the world. Its strength to weight ratio is marginally higher than teak wood and nearly double that of mild steel. Processing bamboo for boards uses energy which is 1/4 of that for concrete and 1/3 of wood to create a building material of similar capacities. In comparison to steel, bamboo uses 1/50th the energy. Bamboo is the fastest growing biomass and it is a renewable resource, being a grass, not timber. Bamboo substitutes wood timber and thus conserves forest, and it conserves and binds soil and sequesters carbon. In terms of a scale of eco-friendliness, therefore, bamboo is a material that is 4 times blessed. The technical and performance parameters of bamboo housing and structures would surprise and warm the hearts of prospective buyers and users.
When we heard about these prefabricated huts, we were not sure that whether they will be working well in the Kashmir, because the situation in the Kashmir is slightly different. We have weather, inclement weather during winter, but we had no choice. And when we started with these bamboo huts, we were so happy to see them because they worked very well for all these 3 years in the university.
A prefab bamboo housing or structure means durability, nearly 30 years life and weather resistant, earthquake resistant and designed for withstanding high winds, fire resistant, lightweight, modular and interchangeable, easy to construct and maintain, requires minimal skilled labor, good thermal and acoustic properties, easily transported and can be redeployed in a new location with negligible losses.
Prefab structure, you can make a structure say for 36 feet by 16 feet or 20 feet, you can fix within 1 day by 4 persons. And again you can dismantle it within 1 day by 4 persons. And again can put another place. Then you can make hundreds of shelters, hundreds of houses in a day.
Other than the prefab, board-based structures, there are whole bamboo structures and housing. Their utility and future lies in 3 areas: mass housing needs in rural areas, disaster relief and rehabilitation shelters, cottages and structures in the tourism sector.
This house was done in 2000 and almost 9 years old. We have tested for Kobe earthquake, and also we have tested up to the Richter scale 8. After the test, we have observed that the 10 feet by 10 feet house has no visible cracks.
In the traditional bamboo houses, which are still widely used, the use of bamboo is basically secondary as a semi-load bearing element and as infill material in timber framed houses, as for example, a typical Assam house. However, the use of engineering principles, bamboo pressure treatment for termites and pests, tested jointing techniques, and the choice to use boards in combination have enabled radical improvements at little cost and opened new possibilities and innovative practices. Technologies now exist that ensure that foundations are minimized, wall panels are non-load bearing, and basic components are available locally. It is possible today to engage in modular construction in both boards and whole bamboo and carry out either prefabrication or fabrication in situ. These vital technology improvements have created conditions for the development of enterprises and markets on an all-India basis for supplying whole bamboo and prefab engineered bamboo housing units, structures and shelters. Under the overall coordination of the NMBA, these breakthroughs have happened as a result of research, tests and validation carried out by a number of institutions. Prominent among them are the IPI-RTI, the Building Materials and Technology Promotion Council, Wondergrass and many more.
We have very clearly demonstrated that bamboo is a poor man's timber and it can be utilized for construction of good houses, cost-effective houses, durable houses. And not only that, we have tested each and every component of the bamboo houses that has been developed, and its life also has been predicted by undertaking the weathering study, by undertaking the testing in our laboratory at an accelerated testing using the accelerated testing method for predicting the life of the bamboo and bamboo based product. And I considered bamboo as a most economically viable raw material which is available as on date for construction of the bamboo and bamboo based housing system.
Bamboo cottages and resort structures are slowly becoming popular, essentially in the western parts, coastal areas and forested regions in the country. The realization has dawned that timber-based cottages are unsustainable and undesirable in view of the problems of forest depletion. Bamboo structures and materials are ideal for use in ecotourism themes and green resorts. The NMBA has recently built 2 cottages for the ITDC at Pondicherry for their coastal resort property. There are exciting possibilities in terms of design, interiors, finished panels and bamboo flooring. There is another area where bamboo structures can play a crucial social role. That is, as a construction material of choice, both for disaster prevention and disaster relief. The properties are lightweight, modular, capable of prefabrication and fabrication in situ, easy and quick erection, usage of local materials and skills, make them the ideal shelters to meet the immediate and later the permanent housing needs of people in disaster-affected areas.
We have already seen that bamboo can play a lead role in providing housing and shelters solutions in disaster situations. For example, in the post-tsunami rehabilitation efforts in the Andaman and Nicobar Islands, about 80 crores worth of bamboo material was supplied even when the industry was in its infancy. And there is a very strong case that bamboo shelters and bamboo housing have to be a very necessary part of any disaster relief activity or even a disaster prevention strategy.
For tsunami victims, 5,000 houses were constructed entirely on bamboo. It's a prefab structure. In a place like Andaman and Nicobar, it's very difficult to construct a regular concrete wall and a concrete structure. Only because of the bamboo, that too prefab structure, the bamboo structures were made in the mainland, and it was quickly taken, erected, and the project was completed in time.
There is even a strong case for maintaining a minimum inventory of prefab bamboo shelters to be utilized quickly to meet the temporary housing needs in the event of a disaster like floods, earthquake and cyclone and so on. There is certainly no doubt that in times to come, bamboo shelters have to constitute a core component of a disaster management system. Recognizing this opportunity, the NMBA has recently earmarked